All right. So over to optical isomerism. Optical isomerism. Now, this optical isomerism, why it is called optical isomerism, is because of the fact that the compounds that exhibit or that shows this isomerism, they rotate plane polarized light. One rotates the polarized light to the right, and the other one rotates the polarized light to the what? Left. You know what I mean by polarized light? That is light traveling in one direction. You know, light waves, they are scattered in many directions, but this one is traveling in what? In one direction. So the one that rotates plane polarized light to the right is called, we call it dextrorotatory. While the one that rotates to the left, we call it level rotatory. Level rotatory. These are what these compounds do. So, I've defined stereoisomerism. This is one of another part of it. So now, you see these are the two possible isomers of stereo in optical isomerism. Two possible optical isomers. So, see, they are mirror images of each other. Look at this. Don't see how I draw this thing. This diagram is not that perfect, but just use it to understand this thing. Just observe this. This thing is going like this. Then this one should be going like this. Okay, supposed to like draw it like this, so that it will resemble a mirror image. Okay, mirror image. Your image in the mirror is opposite of you. Okay, your reflection is opposite of you. Okay, in every sense. Like in the mirror, your right will become your left will become your right. So this is it. Now you see, they are mirror images of each other. So you see how this one is going like this one should be going ahead. You see, this one actually, let me share this. Good. Now, this one is going, this one ahead, just like the way it is in the mirror. So they are mirror images of each other. Now, see what actually happens here. Before I go to details, know that the number of optical isomers is equal to 2 raised to power n. That is, this one has a formula. Yes, this one has a formula, unlike the one of structural isomers. This one has a formula, where n is the number of chiral centers. Chiral centers. You see, this carbon here is called the chiral carbon. That is the carbon bonded to 4 different functional groups. Now, let's say we have functional groups like this is CH3, this is COOH, this is OH, and this is what? H. Let's have it like this. You see this carbon? This carbon is the chiral carbon. You see this symbol here? We call this, this is the wedge symbol. This is the wedge, and this one, I think I've forgotten the name, just take it as a symbol. Now, this one represents the bond that is in front of you. That is the bond in front of you. This is a 3-dimensional diagram. Do you understand? It's a 3-dimensional structure. This is a tetrahedra. Okay? Yes. So this one is the bond, the carbon bond in front of you. This one is the carbon bond at the back, as at the back of this board. This one is at the front of this board. This one is at the back of this board. These two are on the plane of this board. These two now, they are on the plane of this board. Now, let me show you how to do this, how to write the isomers. Now, This is CH3. If you come here, instead of writing CH3, like you imagine a mirror image, you write H3C, like a reflection of this one. Okay? If you come here, this is COOH. You now like from back, like you count, you write backwards. So this will be HOOC. You see? So these ones, these ones are at the front. So it will not be disturbed. It will just remain like this. Okay. So this is how we do it. Okay. So this is all about optical isomerism and optical isomers. You see, in the other stereoisomer, there are two possible forms, cis and trans form. In this one, there are also two possible forms. Do you understand? So this is it. So we have the one that is distro rotatory and what? Nivo rotatory. The one that rotates to the right and the one that rotates plane polarized light to the left. Okay? So they have two forms. Okay? So that is optical isomerism because of the fact that they rotate plane polarized light. Yes, and they can be called enantiometers. Yes, enantiometer because they are superposed. Okay, they are superposed. That's why they can be called what? Enantiometers. Okay, now see you in my next video. I don't know anyway. My next video I will know the topic I will go into. Better.